Alright, so in this video we're going to look at what is the difference between gauge pressure, absolute pressure, and different types of pressure measurements. Okay, so these are some of those more real-world examples of pressures, right, or where pressure is used. So the first thing is gauge pressure. So gauge pressure, right, is the pressure relative to atmospheric pressure. So gauge pressure is positive for pressures above atmospheric pressure and negative for pressures below it. One way you can think of gauge pressure is if I took a gauge, right, a measuring device, down, this is the pressure I'm reading. It's not giving me something called absolute pressure because I'm not factoring in the atmospheric pressure. And that's what absolute pressure does, right? And so absolute pressure is atmospheric pressure plus gauge pressure, where gauge pressure is rho GH. Right, so P gauge is that rho GH number that, or value that we were using before. And so absolute pressure is given the symbol PABS. Gauge pressure, you can call it P capital G or P gauge, whichever one you want to use. And then atmospheric pressure is PATM. But remember, atmospheric pressure has a value of 1.01 times 10 to the 5th pascals, right? So if they give you anything other than that, you need to convert to this number, okay? Now, here are some real-world examples of where this is used. So, mercury manometers are a class of devices that are used to measure blood pressure. The cool name, and it's always a good day when you can say this name, the sphygmomanometer. Right, that is the technical name for the blood pressure cuff that you when you go to a doctor's office. Okay, and so systolic pressure, right, is the maximum blood pressure and is measured by noting the value of H, or the height, when the blood flow beings as cuff pressure is lowered. Okay. Oh, this should say begins. All right. And so diastolic pressure, right, is the minimum blood pressure and is measured by noting H when the blood flows without interruption. Okay. And so it's like when it gets squeezed, your artery's closed, right, and then it slowly opens, and they're going to give you numbers of like 120 over 80. Okay, and what that means, so a typical blood pressure for a high school student is 120 over 80. And what that's telling you is that the mercury in the device, right, raises 120 millimeters of mercury at systolic and 80 millimeters at diastolic. Okay, again, that's all in that device. Oh, sorry, I was just drawing. I thought I had switch that off to scroll up. All right, so here's just and so I do want to point out, like, so there are different units for pressure. So 1 atmosphere is 760 millimeters of mercury, and what that literally means is at 1 atmosphere, if you had a mercury barometer, it would rise 760 millimeters, which is, you know, short of a meter, which we also know is 1.01 times 10 to the 5th pascals, which is 101 kilopascals, but it's also 14.7 pounds per square inch, right? So these are the conversion factors that you would encounter here. And so this one talks about intravenous infusions are usually made with the help of the gravitational force assuming that the density of the fluid being administered is 1.0 grams per milliliter, at what height should the IV bag be placed above the entry point so that the fluid enters the vein if the blood pressure in the vein is 18 millimeters of mercury above atmospheric pressure? Assume the IV bag is collapsible, right? And so what we need to do is we need to do some conversions here, first of all. We know that, so 1 gram per milliliter, and so that's going to be 1 kilogram is 1,000 grams, right? And so there's 1,000,000 milliliters in 1 cubic meter, and so it's going to be 1,000 kilograms per cubic meter is going to be the density of our fluid. We also have to convert the pressure, so it tells us that the blood pressure is 18 millimeters of mercury, which we're going to say, here's a different conversion factor. 1 millimeter of mercury is 133 pascals. You can also use, if you want a more realistic or a more, just using the atmospheric pressure ones, and it doesn't matter because you would get the same answer because it's, right. So I'd say 760 millimeters of mercury is 1.01 times 10 to the 5th pascals, and so that would tell me it's going to be 2,400 pascals. Okay, and now I can just use my equation, P equals rho GH, and so I'm going to do H equals P over rho G, and so that'll be 2,400 pascals over 1,000 times 9.81, and so the height would be about 1/4 of a meter, right? 0.245 meters. Okay. Now, another class of devices is a barometer, right? So the difference is barometers are going to measure atmospheric pressure. And so what happens is, and you can see in our diagram here, is that the atmospheric pressure is going to push down on this mercury, and it's going to cause it to go up or down in the tube based on the pressure, right? So if atmospheric pressure will tell me that this will rise 760 millimeters, right, at standard. If I have heavier air, it's going to push more, and my barometer is going to raise higher. If I have less, right, the mercury is going to push up on the air, and it's going to cause that to become lower. So the device measures atmospheric pressure rather than gauge pressure. So when atmospheric pressure varies, the mercury rises or falls, right, based on that. Now, here in the United States, when we look at news broadcasts and they tell us, like, here's the atmospheric pressure, we're actually using inches of mercury when in actuality it's the SI unit is millimeters of mercury, if you want to say it that way. Okay. So in the next video, we're going to talk about a Greek scientist famous for the story of Eureka, and so we're going to dive into Archimedes' principle.